According to the 2020 National Electrical Code, NEC cables must be secured within 12 inches of every box they enter. This requirement is in place to prevent the cable from being pulled out of the box, which could create a hazardous condition. Arlington's 1/2-inch black NEC cable bushings are specifically designed to meet this crucial requirement. These bushings are typically manufactured from a durable plastic material, providing a robust and reliable solution for securing NEC cables. A key feature of these bushings is their clamping mechanism. This mechanism is designed to grip the cable firmly inside the box, ensuring that it remains securely in place. The location of the clamping mechanism is also important. In the case of Arlington's bushings, the clamping mechanism is positioned inside the box. This design minimizes the protrusion of the bushing and prevents it from interfering with the installation of other devices within the box. The fact that these bushings are listed by Underwriters Laboratories, commonly referred to as UL, is another important factor to consider. UL listing indicates that the product has been tested and meets specific safety standards. This provides assurance that the bushings are suitable for their intended purpose and can be used in accordance with the National Electrical Code. Therefore, these UL-listed Arlington 1/2-inch NEC cable bushings can be counted as a means of securing NEC cables within boxes. This means that they satisfy the NEC requirement for securing cables within a specified distance from the box, contributing to safe and compliant electrical installation. When installing NEC cable, it's important to understand several key aspects to ensure compliance with the National Electrical Code and maintain electrical safety. Firstly, always refer to the latest edition of the NEC for the most up-to-date requirements. Electrical codes are subject to change, and it's crucial to follow the most current regulations. Secondly, NEC cable, often referred to as non-metallic sheathed cable, is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed within a non-metallic sheath. Thirdly, boxes, typically made of metal or plastic, are used to house electrical connections and protect them from damage. The NEC specifies requirements for the type and size of boxes to be used in different applications. Fourthly, securing NEC cable within boxes is essential to prevent strain on the connections and ensure that the cable cannot be pulled out. The NEC mandates that NEC cable be secured within 12 inches of every box it enters. Fifthly, cable clamps and bushings are devices used to secure NEC cable to boxes. They provide a mechanical connection that prevents the cable from being pulled out. When selecting cable clamps and bushings, make sure they are appropriate for the size and type of cable being used. Sixthly, UL listing indicates that a product has been tested and certified by Underwriters Laboratories to meet specific safety standards. Using UL-listed products is a good practice to ensure electrical safety. Seventhly, proper installation techniques are crucial for ensuring the safety and reliability of electrical systems. Follow the manufacturer's instructions for installing cable clamps and bushings, and make sure that all connections are tight and secure. Eighthly, electrical inspections are typically required to verify that electrical work complies with the NEC. Contact your local building department to schedule an inspection after completing any electrical work. Ninthly, consider consulting with a qualified electrician if you are unsure about any aspect of NEC cable installation. A licensed electrician can provide expert advice and ensure that the work is done safely and in compliance with the NEC. And tenthly, always prioritize electrical safety. Turn off the power before working on any electrical circuits, and take precautions to avoid electric shock. Understanding box fill calculations is important to ensure safe and compliant electrical installations. Section 314.16 of the National Electrical Code provides detailed guidelines on how to calculate the maximum number of conductors, devices, and fittings that can be installed in a box. To determine the correct box size, you need to account for several factors, including the number and size of conductors, the number of devices such as switches and receptacles, and the presence of any internal cable clamps or fittings. Each of these elements contributes to the overall box fill. The NEC specifies the allowable fill for different box sizes and types. These values are based on the volume of the box in cubic inches. The general rule is that the total volume of conductors, devices, and fittings in a box cannot exceed the box's allowable fill volume. To perform a box fill calculation, firstly, count the number of conductors in the box. This includes all insulated conductors, both current carrying and non-current carrying. Each conductor is counted as one conductor. Secondly, count the number of device yokes in the box. A device yoke is the mounting strap for a switch, receptacle, or other device. Each device yoke is counted as 2 conductors. Thirdly, count the number of equipment grounding conductors entering the box. All equipment grounding conductors are counted as 1 conductor, regardless of the number of individual grounding wires. Fourthly, count the number of internal cable clamps in the box. Each internal cable clamp is counted as 1 conductor. Fifthly, if the box contains any unused conductor fill allowances, they must be included in the calculation. Unused fill allowances typically occur when a conductor enters the box but does not terminate on a device within the box. Sixthly, determine the volume of each conductor, device yoke, equipment grounding conductor, and internal cable clamp based on the wire size. The NEC provides tables that list the volume occupied by each of these elements for different wire sizes. Seventhly, add up the volumes of all the conductors, device yokes, equipment grounding conductors, and internal cable clamps to obtain the total volume of fill in the box. Eighthly, compare the total volume of fill to the allowable fill volume for the box size and type. If the total volume of fill exceeds the allowable fill volume, you must use a larger box or reduce the number of conductors, devices, or fittings in the box. Ninthly, box fill calculations can be complex, especially when dealing with multiple wire sizes and device types. Using a box fill calculator or consulting with a qualified electrician can help ensure that the calculations are accurate and that the installation complies with the NEC. Tenthly, remember that box fill calculations are not just about complying with the NEC. They are also about ensuring the safety and reliability of the electrical system. Overfilled boxes can overheat and cause fires. Proper box fill helps prevent these hazards. When working with metal boxes and NM cable, several specific considerations come into play. Firstly, metal boxes must be properly grounded to provide a safe path for fault current. This typically involves connecting a grounding conductor to the box using a grounding screw or clip. Secondly, when NM cable enters a metal box, the cable must be protected from abrasion by the sharp edges of the box. This is typically achieved by using cable clamps or bushings that are specifically designed for use with metal boxes. Thirdly, metal boxes can be used in a variety of applications, including both concealed and exposed wiring. However, the NEC has specific requirements for the type of metal box that can be used in different locations. Fourthly, when installing NM cable in metal boxes, it is important to ensure that the cable is properly supported and secured. The NEC specifies the maximum spacing between cable supports, which varies depending on the size and type of cable. Fifthly, metal boxes are available in a variety of sizes and shapes to accommodate different wiring configurations. Choose a box that is large enough to accommodate all of the conductors, devices, and fittings that will be installed in the box. Sixthly, metal boxes can be made of steel or aluminum. Steel boxes are typically stronger and more durable than aluminum boxes, but they are also heavier and more expensive. Aluminum boxes are lighter and less expensive, but they are not as strong. Seventhly, metal boxes must be installed in accordance with the manufacturer's instructions. This includes properly securing the box to the wall or ceiling and ensuring that all connections are tight and secure. Eighthly, metal boxes can be used in both dry and damp locations. However, the NEC has specific requirements for the type of metal box that can be used in damp locations. Ninthly, when working with metal boxes, it is important to take precautions to avoid electric shock. Turn off the power before working on any electrical circuits, and use insulated tools. Tenthly, metal boxes can be reused, but they must be inspected for damage before being reused. Damaged boxes should be replaced. The type of cable bushing used with NM cable entering a metal box can affect the box fill calculation. While the bushing itself might not directly contribute to the conductor count, its presence can influence the overall fill. Firstly, some bushings, especially those with integrated clamps, might take up space inside the box. This can indirectly reduce the available volume for conductors and devices. Secondly, if the bushing is large or bulky, it could limit the number of conductors that can be neatly and safely arranged within the box. This could lead to overcrowding and potentially affect the box fill calculation. Thirdly, certain types of bushings might require additional space around them for proper installation and maintenance. This space needs to be considered when determining the overall box fill. Fourthly, when using bushings with integrated clamps, it's important to ensure that the clamp is properly sized for the cable being used. An improperly sized clamp could damage the cable or fail to secure it properly. Fifthly, the NEC does not explicitly state that cable bushings must be counted as conductors or in box fill calculation. However, the code does require that all devices and fittings that are installed in a box be accounted for. Sixthly, when in doubt about whether a particular type of cable bushing affects the box fill calculation, it's best to consult with a qualified electrician or electrical inspector. They can provide guidance based on the specific installation and the requirements of the local electrical code. Seventhly, some jurisdictions may have specific rules or interpretations regarding the impact of cable bushings on box fill calculations. It's important to be aware of these local requirements and follow them accordingly. Eighthly, when selecting cable bushings, choose a type that is appropriate for the size and type of cable being used, as well as the type of box. This will help ensure a safe and compliant installation. Ninthly, proper installation of cable bushings is essential for protecting the cable from damage and ensuring a secure connection to the box. Follow the manufacturer's instructions for installing cable bushings. Tenthly, remember that box fill calculations are not just about meeting the requirements of the NEC. They are also about ensuring the safety and reliability of the electrical system. Properly sized and filled boxes help prevent overheating and other hazards. When installing electrical wiring, it's crucial to adhere to the National Electrical Code to ensure safety and prevent hazards. Section 314.16 addresses the requirements for box fill, which refers to the maximum number of conductors, devices, and fittings that can be installed in an electrical box. Understanding and complying with these requirements is essential for safe and reliable electrical installations. Firstly, the NEC specifies the allowable fill for different box sizes and types. These values are based on the volume of the box in cubic inches. The general rule is that the total volume of conductors, devices, and fittings in a box cannot exceed the box's allowable fill volume. Secondly, to calculate the box fill, you need to account for several factors, including the number and size of conductors, the number of devices such as switches and receptacles, and the presence of any internal cable clamps or fittings. Each of these elements contributes to the overall box fill. Thirdly, each conductor that enters the box, whether it's a hot, neutral, or ground wire, counts toward the box fill. The size of the conductor determines the amount of space it occupies in the box. Fourthly, device yokes, which are the mounting straps for switches and receptacles, also contribute to the box fill. Each device yoke is counted as 2 conductors. Fifthly, equipment grounding conductors are counted as 1 conductor, regardless of the number of individual grounding wires. Sixthly, internal cable clamps, which are used to secure cables to the box, are also counted as 1 conductor. Seventhly, if the box contains any unused conductor fill allowances, they must be included in the calculation. Unused fill allowances typically occur when a conductor enters the box but does not terminate on a device within the box. Eighthly, the NEC provides tables that list the volume occupied by each conductor, device yoke, equipment grounding conductor, and internal cable clamp for different wire sizes. These tables are used to determine the total volume of fill in the box. Ninthly, it's important to note that the NEC provides separate rules for calculating box fill in different types of boxes, such as metal boxes and non-metallic boxes. The rules may vary depending on the type of box. Tenthly, box fill calculations can be complex, especially when dealing with multiple wire sizes and device types. Using a box fill calculator or consulting with a qualified electrician can help ensure that the calculations are accurate and that the installation complies with the NEC. In general, when NM cable enters a metal box, it's crucial to use appropriate fittings to protect the cable from damage and ensure secure connection. The choice of fitting can influence the overall box fill and the ease of installation. Firstly, cable clamps are commonly used to secure NM cable to metal boxes. They provide a mechanical connection that prevents the cable from being pulled out of the box. Secondly, bushings are used to protect the cable from abrasion by the sharp edges of the box. They also help to center the cable in the knockout. Thirdly, some fittings combine the functions of both a cable clamp and a bushing. These combination fittings can simplify the installation and reduce the number of components required. Fourthly, when selecting fittings for NM cable entering metal boxes, it's important to choose fittings that are specifically designed for use with NM cable. These fittings typically have smooth, rounded edges to prevent damage to the cable sheath. Fifthly, the NEC requires that fittings used with NM cable be listed by a recognized testing laboratory, such as Underwriters Laboratories. This ensures that the fittings meet safety standards and are suitable for their intended use. Sixthly, when installing fittings, it's important to follow the manufacturer's instructions. This will help ensure that the fittings are properly installed and provide a secure connection. Seventhly, some fittings require the use of special tools for installation. Make sure you have the necessary tools before starting the installation. Eighthly, the choice of fitting can also affect the box fill calculation. Some fittings may take up more space inside the box than others. Ninthly, when in doubt about the appropriate fitting to use, consult with a qualified electrician or electrical inspector. They can provide guidance based on the specific installation and the requirements of the local electrical code. Tenthly, always prioritize safety when working with electrical wiring. Turn off the power before working on any circuits, and take precautions to avoid electric shock.